To start off, we would like to provide specific definitions of what a fluid is and some other assumptions involved when studying fluid mechanics. So, first off, a fluid is defined as a substance that continuously deforms and flows under a shearing force. So, imagine if we have a body, a body of substance, and this takes up a certain space, so it has a volume and we apply a shearing force across the surface of that body. So any kind of force acting across the surface area of this body of substance here. Now, if this body deforms and flows, so if the shape changes, um, then this is defined as a fluid substance. This includes liquids and gases. You can imagine if you have um, if you have some water and you apply a force across the surface of that water, the water will flow in the direction which you applied your force. Whereas, let's say a solid material, if you have a cube and you apply a force across the surface of that, it may not necessarily deform just because there is a force. It might deform if you apply a large enough force, but it won't deform just because there is a force. And a fluid is also referred as a continuum, or the assumption of a fluid also involves what we call the continuum assumption. So a continuum refers to the idealization that generalizes all molecules and particles as a single homogeneous body. Just to note, this applies to solids as well as fluids, but for the time being, we are only concerned with this application to fluids. So we know that water, for example, we know that water contains a lot of small water molecules. That is what makes up liquid water. However, we are not necessarily concerned about the behavior and properties of every single water molecule. Rather, we are only concerned with this water body as a whole. So the continuum assumption basically means that we are treating water, for example, water um, not as a bunch of small water molecules with different properties. We're treating it as a continuous mass that acts as a single body. So this assumption is frequently applied to fluids, and in most cases, the continuum assumption is valid. The only cases where it's not valid would be when the system we are analyzing has very few molecules or particles to the point that we have to analyze them differently. But for the purposes when studying fluid mechanics, we are safe to assume our systems as a continuum.